Hi everyone, this is Ryan Alvey, Chief Operating Officer of Titronic Software. Just a little bit of background about who we are. We are a NASA contractor, primarily funded by NASA, also servicing the Department of Defense, as well as other large life science companies in the commercial space. Now, before I get into exactly what I want to demonstrate today, let me tell you about kind of why we're here. What we're wanting to introduce is a piece of software we call procedural guidance, or for short, ProG. Now, it's what we believe cutting edge and the first of its kind, as we're introducing procedural guidance in an augmented reality form. What we do and what we try to perfect is protecting the human condition. We've done that multiple times with NASA via grants awarded over the last 20 years. We actually have products working on the International Space Station and products now also going on to the lunar rover and onto the lunar module. From there, we've deduced that technology and we've distilled that value learned over time to what now I'm going to show you here is ProG. Now, what you can see is a platform. What it is, it's intrinsically safe, field deployable. You can see that it's built into just a normal hard hat. What it houses is what's called the Microsoft HoloLens 2. This is your actual viewing augmented reality platform that is XC rated, meaning you do not have to wear safety glasses over this. It's ready and field deployable. Okay guys, now we have the Trimble unit up and running. That is the XR10, which houses our ProG software. What I first want to show you is about 3 different demos of essentially what will highlight the usability, the functionality, and the value distilled from the actual hardware integrated with our software. So first, I'm going to start by pressing the MRTK. You can see it's very intuitive, very easy, very manipulatable. All you have to do is push buttons. All right, so now what you see is a 180-degree example of different demonstrations that I can choose from. Now, the very first one that I am going to start with will be clipping examples. Now, what I want to prove here is exactly what you can do. What you see in front of you is a human heart, cow heart, whatever kind of heart you want to call it. But essentially, we're able to grab them, manipulate them in an augmented reality format. So imagine if you have a piece of equipment, a piece of machinery that you want to manipulate, move, or simulate putting into place to see what happens, this demo will show you that. So what I'm going to do is grab this heart very simply. You can see I can move it all around, very easy. I can also enlarge that heart just by grabbing it on both ends and then making it smaller. Now, within this heart, there's actually some writing. So how do I access the inside of the heart? Well, it's really cool. It's one of 2 ways. Either one, I can grab this ball very simply and put it on that heart, and it provides a window. Now I can see directly in it. Now what's another cool feature is if I want to just enlarge it, I can actually step right through into it and see inside. Now folks, I'm actually inside of either a human heart or a cow heart. Again, very intuitive. Here, what do we have? This is what we call the lunar rover. As you can see, everything is highlighted. Again, this could be any piece of equipment in the world. As we work for NASA, as we're one of their top boutique software developers, we like to use the cool stuff. This is the lunar rover. So you can walk around it. Pure spatial apperception is extremely precise, and everything is described. And also, too, as you walk around it, you can see the labels turning to you, so you can always identify what you are looking at. Another thing as well is I can grab it and move it and take it wherever I want and pin it there. Another thing that I can do is also, just like the heart, enlarge it. So if I wanted to leave that there, let go, take a step back, now I'm able to see it in almost a life-size setting. Okay, now I go back to the home screen, slate examples. Now this is what's nice. So if you're out there on the rig site, or if you're in a facility, you've got procedures that you're looking through the augmented reality HoloLens 2 that we've got built into the intrinsically safe Trimble unit. What you normally do is you have to scroll through different documents. I can move it up, down, manipulate, do whatever I want with it. Over on the next one, it's vertical, up and down. Over on the horizontal one, I can move it wherever I want. Now also what's very cool is I can also move these things just by grabbing them and putting the procedures wherever I want. Meaning, now, I'm looking at a wall. Nothing's there, but imagine that there's a piece of equipment. I now have my procedure here right next to me. I can work on it. It's out of my way, and I can easily vertically scroll through it or horizontally scroll through it. So again, very intuitive, very user-friendly, very easy. Okay, go back to my home screen, and we go to Eye Tracking Target Selection. Now this is one of my favorites. So this essentially is tracking your retina, and as you can see, I'm looking at the blue ball. All right, it's spinning around. I'm now looking at the green ball, spinning around. I'm looking at the red ball, spinning around. I'm moving at the orange ball, spinning around. Now there's two different ways that I can manipulate these. What I want to do is make them explode. I can do that either verbally, or I can do that with my hands. The point that I'm trying to put here is that you can verbally manipulate things while doing other tasks, making it hands-free. So from an HSE perspective, you're protecting that person. So if he's in a confined space where he needs to be able to hold on and make sure that he's secure, he can do that while continuing to push his procedure forward. Now, what I'm going to do is I'm going to explode all the blue balls just by saying the word explode. 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 Okay, now we're going to go to the eye navigation demo. Push the box. This is another one of my favorite ones. First, I'm going to start on just reading auto text. So what it's described, it's an auto eye scroll. So what I will do is I'll just demonstrate reading the paragraph right in front of me. And what's going to happen is your retina is actually being tracked. So it'll scroll at the pace that you read. So as I read, you can see the ball kind of following, and you can start seeing everything moving up. So that's one example of that. Now what I really want to go to is now look at the planet. I can look at either side of the planet. So if I wanted to spin, I can look, and if I wanted to go left, I look at the left side of the planet. If I wanted to spin right, I look at the right side of the planet. Very simple, very intuitive. Very simple, very intuitive. All right, this is another fun one. Okay, so we have a lunar lander. This essentially enables objects to come to you, different polygons. So it's very simple, very easy, and it's verbally cued. So if I wanted to just essentially come to me, I say exactly that. Come to me. So now I'm here. I can take it. I can manipulate it, put it wherever I want, move it, do there, and now I can move on to another task. All right, if I need to send it back, it's very simple. You look at it and send back. And now it's been sent back. So now, if we're looking at essentially a map, what we want to show is eye-supported pan and zoom. So you can do this again just by looking at a certain space within that map. So now I'm going to stare at the middle of the map, and I'm going to say, zoom in. Zoom in. Zoom in. Now I can just look without turning my head and move throughout that map, looking up, down, left, right, you name it. Now, zoom out. Zoom out. Zoom out. So again, these are ways to show you where you don't have to use your hands, but you can control your entire environment by verbal cues, eye tracking, and the overall movements between the retina, as well as, if you needed to, just a finger prompt. All right, guys, let's try to make this a little bit more relevant for you oil and gas folks. We've gone ahead and built in a BOP construction procedure. Essentially, what we're going to do is put together a 13 5/8 10K stack via the ProG software system. Again, this is just very high level, but we just want to show you exactly what the capabilities we have. So from that, I'm going to go ahead and start the procedure. And it's essentially taking the novice to competent, and it'll take the competent to expert in real time by following these procedures. So we'll give it a second for the software to boot up. And now we see the procedure up there. I'm going to grab it, click it, just kind of move it out of the way a little bit. It's getting a little too close. And up here I can see all of the components that make up the stack. Now I can actually grab that stack and I can move it closer to myself and put it in a more manipulatable way where I can start now mocking it up. And actually I can grab it with two hands and rotate it and go that way. So I'm going to make it just a little bit smaller, and then we're going to start from here. So step one, identify the wellhead casing on the ground. So what you're going to notice is the green and yellow flashing actual piece of equipment. That is going to be the step that it's associated to. So essentially, let's pretend that's the wellhead. Okay, so we've identified step one. There is the wellhead. Now, let's go to step number two. Select a gasket to attach to casing. All right, so we have a gasket here identified. We're just going to grab that. That's going to go over there straight on top of that. And now we'll go to step number three. Notice how everything closes out. We want to go ahead and select the single ram to set on the gasket on the casing. So again, there's your single ram. It's highlighted. I grab it, click it. It goes and sets up. Let's go on to the next procedure. Select the gasket, attach that to the single ram. So remember, it's always reminding you to put a gasket in between each component. So many people, I don't know how many times, forget to do that. And then we have really bad seals, and then we have potential well control problems going forward. So I've done step four now. I'm going to go ahead and move forward. Now let's go ahead and select the drilling spool to attach to the gasket on the single ram. Now I've got the drilling spool. I'm going to point at that, click that. That's going to move over. It is now attached. Now normally what happens here, you're going to go ahead and start bolting everything together. You're going to get the guys coming out with a torque wrench. They're going to be torquing everything up to a certain pressure. We actually have the capability to show exactly where that pressure torque is when it's in the perfect range and display it to the user who's doing that in an AR environment, and actually be able to report all of those numbers and that data to ensure the integrity of the bolt, that it's not over torqued and it's not under torqued. So now that I've got the drilling spool attached, I'm going to go ahead and move to the next procedure. And that is number 6. Again, we want to place another gasket. Gasket is placed. Move on to the next procedure. 7. Now we want to go ahead and do the double ram. Obviously, we can see that highlighted. We're going to point at that, click it. It's going to move right to it. All right. We'll close out that procedure. Move forward. Select the gasket to attach the double ram. There's the gasket. Selected. That is now moved. And now we're going to go ahead, close that out. And we're going to go ahead and put the annular on top of that. So now we have completed the stack. We're going to go back. What it's not showing again, the bolting of everything, but that's another piece where we can overlay. We're on the process of doing that. So the point is we can take an AutoCAD drawing and we can manipulate this hologram any which way we can. One, we can use it for training for people who are out there. Another thing too is we can use it for getting in and troubleshooting. And another thing as well is when you're actually with say a drilling contractor actually rigging up the stack itself, you can have what we call a digital twin, which is what you're looking at right here, ensuring that what you are doing in real time, in real life, is accurate. So this is 100% accurate. The procedures are executed. You can also run different sensitivity scenarios against it and see where the failures could be to ensure when you actually do the real procedure that is not going to happen again. We're eliminating the human error element out of rigging up a very highly critical component of a rig site. With that, this demo is done. Okay guys, what we're going to demonstrate now is actual ProG. This is what we call the UIA. It's an actual piece of kit that's used on the International Space Station. It's what the astronauts use to hook up to get water supply, air supply, and also a waistline supply. All right, now what you can see is now I have this floating essential procedural guidance piece of tab, or let's just call it kit. I can grab it, move it, manipulate it, and put it to where I want it. Now what I'm going to do is lock it in place so I keep it out of the way of the actual procedure that I need to do itself, the actual deck. So what you're seeing right here is now I'm going to link procedural guidance, or ProG, with the actual UIA. So what I'm going to do is hit the next button, then I'll hit the next button again, then I'll hit UIA, then I'll hit the next button again, and then I'll hit next. Then I'm going to go ahead and choose the procedure that I want to do. Obviously that's the UIA panel procedure object recognition. All right, that's identify the UIA panel procedure. Okay, I hit the down button to go to the next one. Okay, as you can see, it vectors the user and has a radical floating around exactly what switch I need to flip. Now, due to mirroring and what you're going to be seeing from a video standpoint, it's actually going to be slightly off, but that's again due to that mirroring piece. The actual user itself sees a floating green, flashing green circle and vectors the user as to which switch to flip and where to go. So I'm going to go ahead and flip on the EMU. Now I'm going to go over and look, and now automatically ProG takes me to the next step. Again, it vectors me to another floating radical to turn on the EMU power switch. Again, takes me automatically to the next step. So it's forward leading the user in the procedure. Make sure EV1 1.2 power LEDs are green. It looks like they are. We're good to go. We go on to the next step. All right. This is very important. We want to make sure that we turn on oxygen and get oxygen to our astronaut supply suit. It tells me to go ahead and open that up. Now it takes me to the next procedure, 1.6, open EMU2 oxygen valve. Again, forward leading. The radicals are showing you exactly where you need to be, vectoring the user into a precise location. Open EV1 water supply. I'm going to open that up. And what this does is it documents everything that the operator is doing in the field. And so since it's web-based, anyone from anywhere from around the world can log in and watch the procedure in real time. Also, too, they can communicate back and forth between one another, either through verbal via the HoloLens and seeing video of what the operator is doing, or just verbal cues going back and forth, or via text. Another thing that the program and software can support is actually taking pictures and videos and getting different files and uploading that into the actual procedure itself. So it's telling me I'm on 1.8, open the EV2 water supply valve. Again, it's highlighted. Open that up. It's going to take me again directly to 1.9. Now I need to open up the EV1 water waste valve. Again, highlighted, very intuitive, very easy. Now I'm on step 1.10. This is the telemetry variables. So I need to open up the EV2 water waste. That is open. From there, I need to open the O2 vent. And now I need to locate the matting bolts. So again, the radicals are floating around the matting bolts. I've identified where they're at, one here, one here. Now that I've identified, on to the next procedure. And now I need to connect the SCU. So we've actually built a 3D hologram to show exactly what the unit looks like. So what I'm going to do is now connect the SCU via the hologram, showing me exactly where that placement needs to be. From there, now that that's complete, I go to the next step. I've completed the procedure, and now we're done. So guys, that's it. Just wanted to give you a high-level highlight of exactly the value that we can deliver. Again, remember, intrinsically safe, houses the HoloLens 2, augmented reality, procedural guidance. We're protecting the human condition. We are taking out human error out of all procedures. So with that, I just want to go ahead and close, say thank you for your time. If you need us, call us. We're on the web, www.titronics.com. Love to hear from you. Talk soon.